Welcome back to part 3 of our Isaac Sim series. Today, we are solving industry's $50,000 per hour problem: unexpected equipment failures. In parts 1 and 2, we connected our PLC and animated our pump. Today, we are adding artificial intelligence to predict maintenance needs before failures occur. We'll go from Studio 5000 data through Isaac Sim visualization and to Anaconda AI training, all in real time. Let me show you this complete AI integration. Let me demonstrate our professional environment verification process using multiple approaches for maximum confidence. First, here's our comprehensive AI toolkit overview. Notice how we have all our essential components ready. Scikit-learn for machine learning algorithm, Panda for data manipulation, NumPy for numerical computing, and all our supporting visualization library. Now let's verify this directly in our Anaconda environment. Notice the base environment indicator showing we are in our data science platform. Excellent! With our AI environment fully verified through multiple methods, we are ready to move into data collection and training. Let's switch to Isaac Sim. Before we can train our AI, we need high-quality training data. I'm switching to Isaac Sim where I've set up our data collection node. The key principle: we only collect data during normal, healthy operation. We are teaching the AI what normal looks like so it can detect when things go wrong. Our system monitors 5 critical parameters: temperature, vibration, current, speed, and run status. Perfect. Now let's train our AI with this real pump data. Here's where the magic happens. I'm executing our isolation forest training script. This AI algorithm learns what normal pump operation look like from our collected data. Why isolation forest is only need normal operation data. No failure example required. Perfect for predictive maintenance where failures are rare. Perfect. Now let's deploy this AI in Isaac Sim. Switching to Isaac Sim, I'm adding our AI predictor node to the action graph. This connects our trained model to live PLC data. The system now analyzes temperature, vibration, current, and speed in real time, providing anomaly scores and maintenance prediction. And here's our intelligence alert system: green for normal, yellow for warnings, red for critical maintenance need. Let me test this system with some anomalies. Now for exciting part, testing our AI system. I'm gradually increasing the temperature to simulate overheating. Watch the anomaly score drop and alert activate. Temperature test. Notice how quickly the AI detects the deviation and triggers yellow warning alert. Critical test. As I punch temperature higher, we get red critical alert with maintenance time estimate. This is predictive maintenance in action. Let me wrap up what we have accomplished. In under 8 minutes, we've transformed a basic pump into an intelligent self-monitoring industrial asset. What we accomplished: integrated Studio 5000 data with Isaac Sim, trained AI using Anaconda's machine learning platform, deploy real-time anomaly detection, create intelligence maintenance alert. This is the future of industrial maintenance, preventing failures before they happen. Subscribe for more advanced AI implementation and let me know in the comments what equipment you'd like to see AI enable next.